Okay, Assalamualaikum and a very good morning. Okay, as I promised, today we will have two sections. The first section, we will go on our lecture on Shapley value. And the second hour of our lecture today, we'll have a talk from Mr. Akram Ramadan. He will talk more on Shapley trade. Please, during the talk, ask him a lot of questions. Okay, so all of you can see my slide. I also already upload the slide in the e-learn, and I'm sorry I upload quite late. It's in the morning. Okay, so let's continue. Shapley value. Actually, this is the 14th Nobel Prize in game theory. Uh, okay, so we need to recap important point before we go through on the Shapley value. If you still remember last week lecture under n person's game, when you're looking at n person solution, when you look at the n person solutions, it is a complex higher combination strategy, and usually they have the same payoff. High probability they will have the same payoff. It means that most of the n person strategy will tend towards the same strategy and same payoff. That's why most of the game, what will happen, they will form a coalition. Coalition means an agreement before entering a party, entering a firm, or going to produce the same type of phones or technology. So they tend to combine in the form of group, which we call state variable. Okay, which is called state variable. And do remember here it will involve it payoff, and usually they will cooperate each other, where we call there is a binding agreement. Okay, binding agreement. Why they want to do a binding agreement? If let's say you have 1,000 players, if 50 of them can do binding agreement or form a coalition, at least they can start to win a game by eliminate the next 50 individual players. Okay, and this is the same concept how they work in auctions. Okay, what we're going to look at today is only a first surface in a game. When we go through on the uh, on the information in the week of 6 and 7, then you can know the importance of coalition, especially in the banks. Okay, especially in the banks. Here, we need to understand the transfer utility. Transfer utility means the payoff. Okay, here there is a few things that you need to remember before you go into detail. The first one, what is coalitions? Why we need to do coalition? What will we get? How about current individual payoff? Criteria when do a coalition? How we will divide the fair payoff between players. It's not average, it's a fair payoff. And where we can do the applications of Shapley. Until now, we're still using application of Shapley, even in our governments. Okay, I will let you know what the criteria that they're still applying Shapley value. In here, if you still remember, I already mentioned to you that in John Nash get his first Nobel Prize when he tried to prove the Nash equilibrium for n persons game. And you need to understand when he using n persons game, he proved using Kakutani theorem. Okay, in the Kakutani theorem, as explained in last week, Kakutani theorem mentioning a symmetric n-persons game. It means that all players have the same strategy set. Okay, when you are doing coalition, it means both of your firm, although your firm both are doing handphones, let's say handphones, you will have the same strategy. Example, to advertise or not to advertise, to take it out a new version of phone on or just keep it with the current technology. Okay, so if you switch two players strategies, you switch their payoff and leave others player payoff unchanged. This is a special case of symmetric game. Your payoff depend on what you do and the sum of the actions taken by others. Example, let's say, as in the video, you can see on the Shapley value in the final part of the video that I already upload in our e-learn. Example, let's say me and King Kang Hoi can produce a cookies. If I do alone, I can make it 40 cookies. While if King Kang Hoi do alone, he can produce 30 cookies. But when we combine together, we do coalition together, we can do now, rather than 30 and 40, now we can do 150 cookies. But how my utility for that 150 cookies will be divided into a fair payoff, because I know Ching Kai Hui can produce lesser than me when we are doing it separately. So how are we going to do that? That's the importance of Shapley value. That's why I say that your payoff depend on what you do and the sum of the action taken by others. So when you are saying Shapley value, okay, when you are saying Shapley value, we consider a characteristic functions game. N and V. N refer for number of player. V refer for the value or the payoff or the transfer utility. A value associates to every game V and every player N of a real number. It means we need to have a real number player. That's why it's always that theta I and V equivalent to subset to R positive. Okay, always positive real number. You cannot get say complex real number for every I which equivalent to N. Positive interpretation of the Shapley value. Question: what will be the expected outcome? Because we know, as I mentioned previously, if do separately, I know Majid can do 40, Ching Kang Hui can do 30. But now, what will be the expected outcome of bargaining to share the VN? Okay, but for today, I will just look at Shapley. When we go to the week of 8, we will look back a bit of extension of Shapley on bargaining, how you should bargain. Normative interpretation of the Shapley value. Here we does not call anyone average value or average expected payoff. What we're calling after this in Shapley, we always call fair value. Fair divisions of the worth of the grand coalitions. Okay, when you are saying about Shapley, is actually a heuristic approach. You know, right? What is heuristic approach? Is the advanced approach to solve a game. Okay, partner have to negotiate about the sharing of the value. If they are not going to sharing it, no point you have a coalition. And player must agree on the three main assumptions or points. The first one, each partner must be remunerated. at the level of her contribution. It means her payoff should be paid fairly, okay, or her incremental value. Okay, but the problem with this point, this incremental value depends on the group the players join. We need to calculate a kind of average. That's why I call this one as a fair game, not an average game. We need to calculate a kind of average of the different incremental values. And each one of the n factorial orders has the same probability to appear. It means it also need to agree with the number of order. If you have 3 players, the order should be 1, 2, and 3. Let's say the second combination order is 1, 2, 3. You still need to use the orders that at the same probability to appear. I will show how we can how we going to do this. Okay, and do remember, player must meet in bargaining room to share what they can obtain all together, or we call VN. This is what happened, especially when election. Okay, when election, if let's say the Pakatan or the Perikatan does not have enough seats in the parliament. So what they're going to do in order to form or to or in order to form a government, what they're going to do, they will go bargain with all individual uh, 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 individual who want a parliament seat and try to buy them. Okay, they need to do that in order to form a government. That's one of example. Okay, that's why you can hurt when you already won. Sometimes you can even get 10, 15 million ringgit. Next, they arrive sequentially. So this is also very important. Sequentially here, they arrive sequentially, and the order in which they do so is determined by chance, with all arrival order equally probable. Do remember, when you want to try to solve, you need to have in the correct order, because you will have a combinations of order. Next, each player, when she enters the room, demands and is promised the amount which her participation contributes to the value of the coalitions. In here, if any player going to join a coalition, they need to have a certain value. You cannot be a dummy player. When you being a dummy player, we consider you as zero. Shapley, zero. It means your contribution to the coalitions is zero. So no point having you in the coalitions, because the main aim of the coalitions is to form a better chances or better profits. And this is the definitions. Consider a game UV. U is the universe of player, and consider N is a carrier of V. It means that U is the universe. Under U, subset of U, we can have N. Okay, where for every S subset universe, the value of S consider as uh, uh, intersect. Okay, S intersect with N. And I, or a player, will call a dummy player if they does not contribute to that value, okay, or to that correlations, as what I have explained previously. If V and W are two characteristics, it means V is a player, W is another player, then we can make sure that the adaptivity is there. Adaptivity means really player V plus player W is a characteristic function such that V plus W times, which is times with the correlations S, equivalent to player value of the V plus the value player for S. So this is under the criteria conditions, which we call adaptivity to the marginal contribution. So in order to solve this one, if you still remember, Lord Shapley, he is the 14th Nobel Prize, have proved the theorem of Shapley using 3 axioms. The first axiom, a game should be symmetric. It means that the value is invariant to any permutations or order. It means you should have a mapping of U onto itself. Okay, what each partner can obtain or contribute should not depend on her alone. Okay, on her alone. It should be a coalition. That's why it's called, the first one should be symmetry. The second axiom we call efficiency. It means that for each carrier of the player, you need to have a certain value before you do a coalition. And if you don't have the coalitions, or you don't have any value to form the coalitions, you are considered that null player or dummy player, which gets 0. Okay, and as mentioned previously, the third axiom called adaptivity. Activity means when you have two different players, you need to add their value separately, and you can add it together to form a coalition. And do remember, two negotiations about different objects are different. What a partner can obtain as a result of two negotiations is just the sum of what she can get in each one. Okay, example, like me and Chang Keng Hui, doing biscuit. What I can get, 40 biscuits or 40 cookies when I'm doing alone, while Keng Hui can get 30 cookies when he's doing alone. But now, when they're doing coalitions, they should get better than what they get when they're doing separately. Okay, and these 3 axioms makes a theorem. A theorem when a unique value functions exist which satisfy axiom 1 to 3 for games with finite carrier. And this is called Shapley value. And this is the formula for Shapley value for every I, or every player which is subset to the N, for in order to get the marginal contribution of that game, it will be the theta I, not theta 1 I, theta I. Theta I, for n player with value, you should get n minus s factorial. And here it means the size. The small n means the size of n, minus s. S is the size of coalition, minus 1 factorial, and summation with the value. And do remember, the important thing is you need to do sequentially and in order. when you're going to find the value for each particular, you need to have a sequential order which already developed by Shapley. Okay, and this is make how he get the Nobel Prize. Do remember he managed to prove for two type of game for this one for n persons. Here he said that a value for the essentials and persons gain is deduced from a set of axioms. It means that in order to make sure we can eliminate some of the player, a value is the transfer utility or the payoff is essentials to reduce some of the player. This is also called a simple bargaining procedure. Okay, and the good thing, finally, a number of simple properties of the value are established. He managed to do 3% constant sum, 4% constant sum, 5% constant sum, 2% general sum, 3% general sum. Basically, we are not going to look at the constant sum. You can go and have a look if you want to find this paper. This paper is available in internet. I'm going to teach how we can do for 2%, 3%, 4%, 5% general sum. And do remember, for 2% it is very easy. You just do 0 or half. While for 3%, you need to know the order. Now, you need to know the order. Even to they have two type of order. We know which one we need to choose. And main important from this result is you need to use the order, and actually they already well established the model. Okay. And here, what we're going to look for today, we are looking at monotone, uniqueness, and adaptivity. The three axioms that I explained previously. Monotone also we can call as symmetry. Uniqueness we can call as yeah, efficiency. Uniqueness we can call for efficiency and adaptivity. Next, we also can look up how this Shapley value also can use for find a veto power. How WHO have a veto power. How veto power in the world is being formed. It's called Shapley Shublik. And finally, we also can look at the core of the game. And do remember, for your midterm test, I will involving with monotone, uniqueness, and adaptivity. Also on power-tail correlations, veto power. Okay, I will give you all around 2 minutes, then we'll continue back. Okay, thank you. Let's continue. Okay, let's look one example. Don't worry, today we go through an example, but on Monday we will do a tutorial. Okay, so let's see example. Let's say you have three players, player one, player two, player three. Look here. If player one do by himself, he will get 1.5 for 4.11. When we have a player two doing alone, she or he can do 2397.40. When we have a player three alone, they can do together 4448.99. Okay, but when player one combine or correlate with player two, you get 3941 3941.51. You can just add this value and this value together. Next, when player 3 have combined with player 1 and 3 will get 5993.1. When player 2 correlate with player 3, you will get 6846.39. And finally, when three of them join hand together, they will get 8390.0. Okay, so here we can do the additivity. It means when we have a different player, you just can add the value when they are doing alone. So next, we already have three players. Now we need to determine what should be the value for each player after they do the correlations. In order to do this, you need to have a marginal contributions. Wait. Okay. You need to have a marginal contribution of players for a given order. If you still remember what I explained previously, you need to use the order. When you have six player, sorry, when you have three player, the order number, so, the order will be six. Okay, so here what I do, I will show you how we get. This is the table developed by Lord Shapley. Lord Shapley. Okay, look at the first order. The first order will be 1, 2, 3. Another one, 1, 3, 2. Okay, this is the first order for the number 1. The second order will be 2, 1, 3, 2, 3, 1. And final order will be 3, 1, 2. Another one, 3, 2, 1. For so this is the order. If you have 4 players, it will be 4 factorial. It means 4 times 3 times 2. You will have 24 players. Okay? 24 order, not 24 player, 24 orders. So what Lord Shapley do, when you have the first order, it means, let's say you are using 1, 2, 3 into the bargaining room. Do remember that it should be happen in a room, right? So what we'll do, if only start from the first player, let's see, that here the Toshiba, Micron, and SK Hynix means Toshiba refer for player number 1, Micron refer for player number 2, SK Hynix refer for player number 3. Okay, I take from example from my master research thesis. The first order, since you start from 1, that's why you only have on the first order is the value of the first player, which is 1544.11. Okay, because you start from the first player and the first row here refer for the first player. The second one, is actually refer for the second player, which is V2. But do remember, we need to do according to the order. That's why when according to the order, 1 enter first, then 2 will be enter. That's why if you want to find for this particular order, the value of the value of their particular payoff, what you should do is, since it accordingly 1, 2. So that's why you need to take what the value will be of 1, 2. It means the value of correlation 1 and 2, and you need to minus what will be the player to value when she or he do alone. We know the coalition of 1 and 2 will be 3941.51. And since we already have an order now, we need to know what is the marginal contribution. Marginal contribution means what will be the value of the payoff, after deduct the his or her own value when they are doing it alone. That's why V12, which is 3941.51, minus with V2 because now we are look at the player number 2. 2397.40. That's why when you take this one, 1 2 is 3941.51 minus with wait yeah minus with 1. Wait I think I do wrong. Wait, try to calculate back. Take the value of 3941. Wait I calculate here. 3941.51 minus 39415. Wait. Okay, wait. Can anyone count for me because I did not bring calculator? Can someone count for me? 3941.51. Okay, let me call someone to help me.
I think should be minus V1.
Yeah. It should be minus V1, right? Who's that?
Yeah. So the answer is 2397.4.
Okay, that's why I'm saying I'm doing wrong here. It's supposed to be V1, right?
Yes,
Okay.
doctor.
Yes, thank you, Gualiang. Okay, that's why I say just now is wrong. It's supposed not minus with V2, it's supposed to be minus with V1 because we need to minus what will be the value after the join correlation and minus with marginal contribution of the previous player. It should be V1 to minus V2. Sorry, V1. That's why you get 23974.40. Okay, same goes when you're doing for the value 3 or the player 3 when you have a coalition because now the order is 1, 2, and 3. That's why you take V 1, 2, 3 minus with V 1, 2, which you will get 4448.99. Okay, so now let's look for the second player. Now the order is we still use 1. It means the first player still enter to the room first. But now after 1 is 3. And next player 2 will be joining them. Okay, will be joining them. Okay, now I'm going to call someone. Ariel, are you there? Ariel Hakim, last week also I tried to call you. You cannot get Ariel? Ariel?
Hello, Doctor.
Yeah. Okay, Ariel.
Yeah.
Look on the first value. On the order of 132. May I
Okay.
know why the value is still the same?
Uh, uh, what do you mean, Doctor?
Huh?
Why the value is still the same?
Yeah, why the value is still the same like the upper order? It means 1, 2, 3. Now for 132, why the value for the first player, which is Toshiba, is still the same?
Uh, what's the Doctor? Not sure, Doctor.
Not sure. Okay, thank you.
Yeah.
Okay, Ahmad Arif.
Yes, doctor.
May I know why the value is still the same?
Uh, I'm still not very clear on Shapley value yet, doctor.
Okay, no,
Sorry, doctor.
no worries. Okay, look here. If we all look here, what the value enter first into the room? Still the first value. Still the first player. If look here, let's say they doing coalition from player 1. Okay, if you look here, start from player 1, they will correlate with player 2, then try to correlate with player 3. So for the first question, why here is only player 1? Because only one player enter and the same players enter to the room. What? That's why the value does not change. While when their second player enter to the room, now the value already have correlation between 1 and 2. But we need to know what is the marginal contribution between the correlation and also the previous player if they play alone. That's why you get V12 minus V2. While the same reason that we use for player 3 when they're playing using first player, second player, and third player. That's why you have the value of correlation 1, 2, 3 minus with the previous correlation, which is 1 and 2. Okay, for this question, if we look here, we are using 1, the same player of 1 for the first order. It means for the first player, we still use the same order, which is 1. But for the second correlation, we already changed it into 3, then 2. That's why, since the first player still does not change, that's why we still have V1. Arif, faham tak?
Oh, okay. Okay, Rata. So the
Are you
V1
clear?
is because of the same order lah.
Yes, boy, yes.
Okay, Rata.
Okay. Ariel?
Faham, Doctor, faham.
Okay. Now, someone need to explain to me. Let me call Jack Chai. Morning.
Good morning, doctor.
Morning, Jack Chai. Jack Chai, do you know why we get this value?
Does it mean the
Why we need to take this value minus with this value?
I'm not really sure about that one. Sorry, doctor.
Okay. Never mind. Thank you. Leong Yilin, are you there?
Yes, I'm here, doctor.
Morning. Good morning, girl.
Good morning, doctor.
Okay. Can you explain how you get this value?
Uh, I'm not very sure also.
Okay, no worries. Okay,
Sorry, doctor.
no worries. Thank you. So look here, everyone. Now the if you look here, the order start with 1. Next is not going for 2. If going for 2, definitely we will have this value. V12 minus V1, not V2, V1. But here it start from after the player 1, the form in order to form the coalitions, they go and meet first the player 3, not the player 2. Okay, that's why what happened, since we already have the player 3 here, we need to use the coalition, the 3 coalitions, 1, 2, and 3. You cannot simply take 2, since although you have here 3, you cannot simply take 2, because since you already involved the player 3, you need to take the full coalitions. The full coalitions minus with the current coalition 1 and 3. Leong, Yilin, can you understand or not?
Uh, kind of.
Yeah, it means that when you have the player 1 and player 3, the Shapley lot mentioned that we need to take the full coalition, which is 1 and 1, 2, and 3. And next, need to minus what the coalition currently doing, 1 and 3. Understand or not?
Uh, okay, doctor.
Thank you. So next, if you look on the third one, after 3, then the player 2 came in. It means now it's already a different order. That's why for the when we have the third when we have the third combination, look here. Do remember the Toshiba is referred for the player 1, Micron refer to the player 2, and SK Hynix refer for player 3. When you look at the micron just now, it's supposed to have player 2 come in first. But since now player 3 came in after 1, that's why we need to calculate the marginal contribution of player 2. when you want to calculate the marginal contribution of player 2, what you should do, you just take the full coalitions because Micron is player number 2 and SK Ionis actually is a player number 3. So that's why you take the full coalitions 1, 2, 3 and minus with the current coalitions. It means the current coalition means 1 and 3. Okay, because you want to know what will be the marginal contribution if Micron play alone. Micron does not involve in the coalition yet. Okay, so what you can do, and you know the Micron, when they play alone, they will always get 2397.40. This is the idea generated by Lord Shapley, and actually it means that because the player 2 does not involve in the game of the Micron, that's why they tend to get a similar value. Next, we look at 1 and 3 already correlate. Next, when 2 involving in the game, that's why we can say the marginal contribution will be, it does not, it means that you just take the V13, what the coalition doing now, and minus with V1. When you have 1, the order of 1, 3, and 2. Okay, don't worry, we will do a lot of exercise for this particular Shapley value, and we will get to know how will be the order. So when you have a different type of the order, you will have a different type of marginal contribution for every cell matrix. Like here, when you have 2, 1, 3, next you have 2, 3, 1, you can see the order are already start to be different. Like when you have the order of 2, when you have the order of 2, currently you know that V not starting with the 1, Toshiba actually are the first player, but since we already start with 2, that's why you take the correlation of 1, 2 minus with the current correlation which is V2. That's why you get 1544.11. Next, for V2, you know the V2. Now the order is the on the 2. That's why you get the same value for the 2 here and down here. And you do the same order calculation for the whole cell matrix. Never mind, you just go through first. And finally, what I'm going to tell all of you is here, the total marginal contribution. When you already start to calculate everything according to the cell matrices, you will get marginal contributions for player 1, player 2, player 3, while you add on the value here. When you add on all the value here, you will get total marginal contribution for each player. Next, what you should do is you take the value example when you have a player 1, 9264.66, you just divide it back with how many order total together. In this case, we have 6 order, and this is will be your first order value, second order value, and third order value. And if you look here, the first order, second order, and third order, while using whatever Lord Shapley already established on the formulation, you will get the same value back. That's why we mentioned that the value should be same when they are doing alone, V1, V2, V3. For this case, it's directly same because we did not have any additional information yet. Okay, this is a simple Shapley value. Okay, next, when you add this value together, 9264.66 plus 14384.4 plus 26693.94, you will get around 50343. And when you add together and divide it by 6, you will get 8390.5, which is the value of correlation 1, 2, and 3. You can look back here. 8390.5. Okay, that's why Lord Shapley able to win the Nobel Prize, because from this breakthrough and established formula, they can apply the Shapley value in a lot of fields, especially on cost allocation, transportation, congestion problem, politics, decision making, queuing, investment, and more on. And the first assignment for all of you after mid-semester break, it will be on the Shapley value applications. We are not going to discuss it now. Okay. So never mind. This one we will do in coming Monday. And also, not only this one, we also will look at the investment game, which always being used in the insurance companies. And this one on politics is very easy. We can do even in next 10 minutes. Okay, so let's hold first for this lecture. Let me call I will give you all of you around 5 minutes of rest. Please make sure come back sharp at 11:55, because we're going to have a talk by Mr. Akram Ramadan on Shapley trade. And do remember, please ask him a lot of questions. And this is what means of Shapley value, and Shapley value can be used for more than thousands players. Okay, thank you. So just give me around 5 minutes. I'll try to call him back. Thank you.